Welcome to In Depth with Academia. I'm Richard Price, CEO of academia.edu, and I'm excited to dive, as always, into some fascinating academic research with you today. As usual, I want to emphasize I'm presenting today's paper neutrally, not endorsing it personally, but rather offering a little window into the cutting edge of thought so you can consider for yourself what it might mean for you. So, today we're looking at a paper by David Lush called The Magnetic Force as a Kinematical Consequence of the Thomas Precession. Whoa, okay, that is a title. But seriously, what's going on here? What is this core question, and why might it matter to, well, you and me, the listeners who aren't necessarily electrical engineers or theoretical physicists? At its heart, Lush's paper asks, why does the magnetic force exist the way it does? Is there some deeper reason buried in the way motion and relativity work together beyond, Maxwell's equations and what we memorize in classrooms? Lush's angle is to examine whether the magnetic force is essentially a result of the Thomas precession, a quirky effect from relativity that happens when you have rotating and accelerating reference frames. Got that? Thomas precession. Sounds like a ballet move or something, but it's this weird twist, literally a twist, that comes out of relativity. Why is this significant? Well, understanding forces differently, or even slightly, can sometimes pave the way to new insights, technologies, or honestly just shake up how we teach and learn physics. And maybe there's even a chance of linking electromagnetic theory with other fundamental forces like the strong or weak nuclear forces, which is a big deal if it's really there. Okay, let's talk about what Lush actually does in this paper. He's not just making philosophical points, he's crunching through the math and physical setups of how two charged particles interact, one creating a field, the other moving through it. The big move here is looking at things from the perspective of the accelerating particle, as if you're riding along with it. It's not just sitting in the lab watching things happen, but more like hitching a ride with the electron as it zips through space. So here's the insight. Lush argues that what we call the magnetic force, which is this extra sideways force moving charges experience, can be understood as emerging from adjustments you have to make when considering how reference frames twist and rotate due to Thomas precession. In other words, the math you'd use to account for rotational fake forces, Coriolis force, like when you're spinning on a merry-go-round. That exact kind of math shows up in the way the magnetic force acts. It's as if the universe is saying, sure, I'll give you a magnetic force, but really it's just a clever dance of your reference frames. Wild, right? And here's something neat. Lush claims that if you set up the equations for the so-called anti-Coriolis force, the numbers basically match the normal formula for the magnetic part of the Lorentz force, that V cross B thing from high school. So, maybe, just maybe, the magnetic force is what you get from this relativistic twisting. Not something laid on top, but totally baked in. There's more. Lush even wonders if, under extreme conditions, like really high speeds and super short distances, think, inside a proton, similar logic might give rise to an anti-centrifugal force. That's a force always pulling in, possibly able to overcome the usual electrical repulsion between two like charges, a tiny bit like the glue in the nucleus of atoms, the strong force. Now, the math suggests this effect might not quite be enough compared with what's measured in the real world, but it's a tantalizing link to keep exploring. And, okay, let me digress for a second. The phrase anti-centrifugal force got me remembering when, as a kid, I'd spin in my desk chair as fast as possible, convinced I was discovering fundamental truths about the universe. But, turns out, maybe I just liked being dizzy. Anyway, where was I? Oh, right. So what does all this mean for you? Well, even if you don't do physics every day, this paper is a kind of story about how reconsidering the basics, asking, why does this force act the way it does, can open up fresh ways of thinking. Maybe it'll get you to peek sideways at a concept you thought you learned ages ago, or maybe just spark that little bit of what if curiosity. I'll say again, I'm not endorsing Lush's arguments. Experimental validation, consensus from the community, all that's how science moves forward. But still, it's exciting to watch thinkers tug at the edges of what we know and see what new patterns emerge. Thanks for listening to In Depth with Academia. Stay curious, remember that the truths of academia are usually just starting points for deeper questions, and, until next time, keep exploring all those whys and hows that make the world so fascinating.